Hello, I've had a question in Unit 2, Lesson 5, about question number 22, projectile motion. So we have a bullet shot horizontally from a gun. So the fact that it's shot horizontally tells me that the following is true. So I'm separating my information into both horizontal and vertical. If it's shot perfectly horizontal, so if this is my bullet and it's heading directly horizontal, it's not moving down at all, which tells me in the vertical, my V1 is going to be 0 meters per second. Because it's moving straight across, it's moving neither up or down. If the bullet's speed exiting the muzzle is 325 meters per second, well, there's only one velocity. It's horizontal when it leaves the barrel. So my horizontal velocity will be 325 meters per second right. And the height of the gun above the ground, so that's vertical information, delta D equals 2 meters. And that's also down. A, how long was the bullet in the air? Well, one piece of information that is rarely provided in these questions is our acceleration due to gravity. So it is also 9.81 meters per second squared down. So the first question is we want to know how long is it in the air? That is defined by our vertical, okay? How long something is in the air is defined by how long it takes for it to drop and hit the ground. We have three pieces of information, 1, 2, and 3. So that means that those three variables, we now can use those to find the kinematics equation that works. Now the vertical is always non-uniform motion. All right, so we're going to be picking one of the 5 equations because acceleration is 9.81, not 0. So we have to pick from one of those 5 equations. So when I look down the list, I see that delta D equals V1t plus 1/2 AT squared. I know my displacement, I know V1, I know acceleration. So this is the equation I'm going to have to use because it has the fourth unknown time. Plugging in my information, I'm going to assume down is positive. So that means that positive 2 equals 0t plus 1/2 9.81 t squared. This is really nice because 0t, that term cancels out for us. So we're left with 2 equals 4.95. Bit of brain cramp here, 4.905. Oops, I'm just going to keep adding decimals here. 4.905 t squared. Isolating for t squared, 4.905. We're going to divide it out on both sides. And then we'll need to square root it. So that gives me about 0.41. I have it on my calculator so that I can just carry it on. I'm showing all steps here. Square root of my answer. So the time of flight, the bullet is in the air for 0.64 seconds. So that's how long it takes for it to fall from its launch point down to the ground. So it's going to follow a parabolic path. The time for this to happen is 0.64 seconds. All right, so therefore. B part. Now, how far did the bullet travel horizontally? If we look back at our horizontal information, we know the horizontal velocity. We're actually looking for the horizontal distance. Time is the only thing that can cross over between vertical and horizontal. It's the only variable. None of the other variables can do this except for time, because time passing horizontally and vertically is the exact same. So in B part, horizontal is always uniform motion. We are not going to be accelerating horizontally in the grade 11 class. So there's only one formula for the horizontal, D equals VT. So we want to know delta D, that's how far the bullet traveled. We know the velocity was 325. I'm laughing because my 3 was not pretty. Times 0.64. So my answer, 0.64 multiplied by 325, we find that it traveled 208 meters to the right because I have my velocity going right. All right. So there is your projectile motion. And like I said, the important thing is this right here, breaking down your information into your 2 columns so you know which is your horizontal information and which is your vertical. Hopefully that helps you out and answers the questions. If you have any other questions, let me know, and I will do what I can to help you.